So you have a clean data set. Your next move is probably predictable. You open a spreadsheet, you launch Posit Cloud, you make a few visuals, you look for the trends you already expect to find. This is what John Tukey called confirmatory data analysis. You're just checking boxes. Worse, you might decide to upload your data to your favorite LLM and ask, what insights do you see in my data? This is how you go from poor analysis to wrong analysis. Your LLM won't analyze your data. It will make up a plausible sounding story, a hallucination, not a real insight. You don't need to use an LLM as an insight generator. You need to use it as a sparring partner. We're going to teach you how to train an LLM to be that world-class sparring partner that helps you analyze data today on ArtScience. Hey there, I'm Kevin Hartman, Associate Professor at the University of Notre Dame and founder of the ArtScience Analytics Institute, where our mission is to make you a better data analyst. Welcome back to Part 3 of the Data Analyst LLM Masterclass. In Part 1, we learned the command framework to direct your AI with better, more effective prompts. In Part 2, we used that framework to act as a data engineer, building surgical pipelines to get clean data with your LLM. Now, we have that clean data set. What do you do next? Analysts typically make two big mistakes here. Either they analyze the data in a way that confirms their own biases, or they treat their LLM as a human analyst, not as the token prediction machine it really is. Let us be clear. An LLM cannot find insights. It doesn't know your business. It doesn't know truth. And as we've discussed, it is designed to produce the most plausible sounding narratives that answer your questions, including, what insights do you see in my data? In this video, I'm going to show you how to use the LLM as a hostile peer reviewer, an expert sparring partner, to destroy your confirmation bias and help you find the sharpest, strongest story in your data. Confirmation bias is a silent killer of analytics. You assume price drives volume. So you plot price versus volume, you see a correlation, you high-five your boss, and you move on. You completely missed the fact that the correlation inverts on Tuesdays because of a competitor's weekly promotion. You missed it because you didn't look for it. The LLM's role in EDA, Exploratory Data Analysis, is not to give you answers. Its role is to broaden, deepen, and strengthen your questions. We're going to use the LLM's vast knowledge of every statistical fallacy and edge case to expose your own blind spots before we present them to stakeholders. This approach relies on a three-step loop that I call clash, code, confirm. First is the clash. You provide your schema with your working hypothesis. You then command the LLM to play devil's advocate. You force it to clash with your assumptions by listing the confounding variables and alternative explanations that you've missed. Second is the code. Once the LLM throws a counter-argument at you, like seasonality might be skewing your correlation, you do not ask it if it is true. You ask it for the mechanism to test it yourself. You demand the specific code or spreadsheet formula to explore the LLM's claim. Third is confirm. This is the most important step because it is the one that the AI cannot do. The AI can write code, but it lacks intuition. It lacks judgment. It cannot distinguish between a breakthrough signal and a data error. This is what you can do. You run the code, you look at the chart, and you use your human judgment to confirm what is real and what is not. The AI is the sparring partner. You are the champion prize fighter. Let's put this into practice. Here's how you run the clash, code, confirm cycle using the 5-tag framework we learned in Part 1 of this masterclass. We start with the role and context tags. Role, act as a skeptical senior statistician. Your goal is to disprove my findings. Context, my data schema is, paste your headers and your schema here. My primary hypothesis is higher marketing spend is driving the increase in new user signups or whatever it is you think is going on in the data. Now for pillar 2 and 3, we set the instructions and the constraints. This is the key. Your main instruction is to find counter arguments. Your constraints are the rules the LLM must follow, like not agreeing with you. Instructions based on my hypothesis in the context list 3 reasons why I might be wrong due to causation. For each reason, suggest a specific visualization or pivot table structure I should create to test if your counterargument is true. Constraints do not agree with me. Provide exactly 3 statistical reasons or confounding variables. See that? By separating the rules, constraints, from the goal, instructions, our prompt is clearer, more logical, and perfectly consistent with the framework we're building. The LLM will now give you its challenge, the clash. It might return a counterargument like, the increase might be due to day-of-week effect, where both spend and signups naturally spike on weekends. Now you execute step 2, the code. If you're using Python or R, ask the LLM to provide you with the specific code that you need to test its counterargument. If you think you have an idea of what you want to plot, you can help it along. Write the Python code to plot signups versus marketing spend, color by day of week, use a scatter plot to separate regression lines for each day. If you're in a spreadsheet like Excel or Google Sheets, you might ask, how do I check this in Excel? Give me the specific pivot table setup and formula to extract day of week from my date column. Finally, step 3, confirm. You take that code and you run it, and you bring your human creativity and judgment to the results. Does this chart make business sense? Is this a day of week effect, or did the marketing team just launch a weekend promo? The AI can't answer that, only you can. An analyst who stops digging the moment the data confirms their bias is not an asset, they are a liability. Your value is not in your ability to generate charts that please your stakeholders. Your value is in your ability to protect them from false confidence. Use the LLM to guard against your own blind spots. Use it to suggest the tests you didn't think to run. But never, ever let it tell you what the data means. That requires judgment. That requires you. Next week, in part 4 of this masterclass, we advance to the main event. We will take our verified data and use the command framework to build advanced predictive models and interpret the results without losing our strategic edge. Thanks so much for watching. If you haven't already, take a moment, subscribe to this channel, like this video, and share it with anyone who you think is interested in data analytics. Here at ArtScience, we are bringing new, exciting, and important videos on data analytics to this channel, and we would love to have you there for the journey. Be sure to check out the links in the description for additional ArtScience resources, and sign up for our newsletter to get exclusive tips, course updates, and more directly in your inbox. Thanks again for watching. We'll see you in the next video.